Hello guys, hope you all are safe. Today we'll be discussing about docking tools. We'll be working on PyRx, how to perform docking using PyRx, which is a virtual screening tool for molecular docking. So before that, I have seen a lot of videos in YouTube in order to learn this tool itself, but there are many other things in order to explore. So I have learned it completely and I have performed various docking using this PyRx. There are many other tools like Autodock. You have Autodock Vina, you have MQ, which is online software, you have GemDock. Okay, but usually I prefer this because it is user friendly and easily you can perform docking with and you can get accurate results. So PyRx, PY stands for Python. So it is a Python built software. On backend, it runs on Autodock Vina. Okay, so we'll start with this. Before that, you need to have patience and completely watch this video till end, so you can master in docking. Okay, you can dock any molecule with respect to your protein and ligand interaction you can perform. So we shall start. Before that, you need to identify which is the protein and which is the target you need to dock. Okay, or protein and ligand. So here I have a paper, dietary flavonoid camphorol mediates anti-inflammatory response. So randomly I have taken this, but you need to do literature survey, which is very important, your background research. So my target here is your IRAK1. Okay, I'll let you know. Before that, your camphorol is being blocking, or what you call, it will inhibit your IRAK1 and IRAK4 receptor, which is involved in the activation of NFK beta. What is NFK beta? It is nuclear factor kappa light, which is responsible for inflammation. So while blocking, there is an anti-inflammatory effect. Now, so this is my receptor. What I'll do, I'll go to RCSB PDB. You can directly search PDB. Okay, and you can type that IRAK1 receptor. Then here you have 6B-FN. See, crystal structure of human. So you can click on this. That selection is also very important. See, IRAK1 is interleukin 1 receptor associate kinase 1 protein. It is a protein. That is your target. Okay. Now you need to identify the native ligand on your receptor. Okay, so you need to go down, scroll down. Yeah, here you have a ligand, DL1 ligand you have, which is a native ligand. Okay, so which is already present in that PDB, in that structure of 6B-FN. What is a DL1? So this is your DL1 ligand, native ligand. I'll tell you why this is useful. After this, you need to just download this in PDB format. I already have, you can see here. Okay, 6B-FN, I already have it. Next, now we'll go to PubChem. PubChem is a ligand database where we have small molecules. I'll search for camphorol. I'll go for download. Here you don't have it in PDB format, don't worry. PyRx is the only this thing which can even work with SDF format, no need of PDB. But when you're working with different other tools, then you need to convert this SDF to PDB. You can watch my previous video using OpenBabel and Corina. I'll put it in the description box. Okay, you can just click on 3D and save. So it will download in your SDF format. I already have it. Okay, now what we'll do is we'll go to pyMol. pyMol is another visualization tool where we can visualize our downloaded molecules. So this is I have opened that 6B-FN. Okay, next I'll put link for this also, how to download this. Next, I'll click on this S. S is nothing but your sequence. So you can see lot of your green and red. So these are your amino acid sequence. These are red are your water molecules. First work, why I'm using this is I need to prepare my protein. There are two preparation. done. First preparation, you need to select this, select, right click, remove. Water molecule should be removed because these are crystal water molecules. Okay, next one more, you have select, right click, remove. Now you need to identify your DL1 ligand. So this is the same ligand but in different position it is bound. One more. Now the important thing here is you have already selected. This is select whatever you have selected. A is action, S is show, H is hide, L is label, C is for cull. Action, you need to extract the object. Your object is extracted. Okay, now you need to rename object. I have already renamed this as your native ligand 6BFN. Okay, I'll show you. Next, you need to, after you're saving, for example, I have already saved but I'm giving another name. Okay, 6BFN for example, I have already saved it. So this is your object. Next, what I'll do is I need to save this. So here you have file, you need to save molecule. Okay, I haven't given name for this. Okay, object, select, and you need to extract object. Here action, you need to rename this object. Okay, I have already done it. Rename it as from object 1 to native ligand 6BFN and just enter. Okay, now this is named. Next, rename. Next, I'll go to this pyMol, this thing, file, save both the molecules individually. Okay, save this. I have already done it. Okay, I have already done it. You need to do it. Next, here I'll show you one thing. This 6BFN now it is a prep ligand. So I have already saved this as prep ligand as you have saved your native ligand. Okay, this prep protein. So this protein prep will not have your water molecule and will not have your DL1 ligand. I'll show this alone. So this is your extracted DL1. Now what is the use? I'll let you know. Okay, after this we'll go to your Discovery Studio. Discovery Studio is similar to pyMol, but more interaction can be seen using Discovery Studio. There are a lot of tools. Have patience and listen. Okay, see here I have saved it as native ligand 6BFN and 6BFN prep. So that prep will not have your native ligand and will not have your water molecule. What I'll do is this 6BFN, I'll just drag and paste it here. So this is your ribbon structure. Right click. When you right click your mouse and you can rotate it. Okay, this is your protein target, prepared one. Okay, select, drag your native ligand, paste it here. You can see your native ligand here. When you scroll your cursor thing button, you can do this. Here you have. Next, what I'm going to do is I'll click on ligand interactions. So this is my ligand interactions. Where is my receptor? So my receptor is here. Why I am doing this, I'll show you. Then click on show 2D diagram. So in order to get the binding site, so you know what is a binding site for the protein? Binding site for the protein is where your ligand will come and bind. Why I need this is, in order to dock with my ligand our ligand is camphorol and quercetin I am taking. So in order to get the binding site, in order to generate the grid parameter, I want this. So you have taken this Now what you need to do is you need to write down this amino acid, note down this amino acid. So I have taken your leucine 291, tyrosine 288, lysine 239, glycine 357, so on, in all the directions. Here one, here one, here one, here one, here one. Okay. After this, you can just close this. Now, after this, we'll go to your PyRx again. Now we'll come back to our PyRx virtual screening tool. Now everything is ready. Now what you need to do is you need to load your molecule. First, file, load molecule. Okay, here it is in my desktop. Here, docking. Now here I need to load my prepared protein. Okay. Which will not include that ligand. Now there is no use of your native ligand. Native ligand is used only not to identify the binding site. That's it. So here you can see your prepared protein. You can scroll and you can check here. Next, you have two chains. Okay, here. Now right click, autodock, make macromolecule. This is your second preparation of your protein.